again, I'm Jonah Crocker. Please help me to welcome Brik Zivkovich, our Research and Development Project Engineer, to discuss designing for maintenance in bioretention systems.
Hello, everyone. My name's Brik. I'm excited to present this today, and my passion is water quality. I love doing green infrastructure and finding new ways to improve our systems, and so I'm thankful for this opportunity to present. So real quickly, just kind of a quick overview, going to kind of give a quick background about some of the work that we do, especially related to green infrastructure, some of the monitoring, and how this has kind of been utilized as part of a regional bioretention study, and some of the key findings that we found that have been incorporated within the newest update to the criteria manual. Some lessons we learned, as well as kind of looking ahead at some of the future research that we're going to continue. So this slide, I've kind of have recycled this a couple different times, but I think it does a good job explaining. So why do we do this research? So definitely for compliance. We also do a lot of things as it relates to improving and update criteria, but also we want to improve our designs. We want to build better systems. We want to help kind of find that right balance between decision-making, operation and maintenance, other types of stormwater management efforts to improve our systems. And so what do we mean by better here? HEFLMS has already been thrown around, higher functioning, lower maintenance. Lower maintenance doesn't mean no maintenance, but it means how can we build something that actually kind of balances this maintenance aspect in. And so Laura had touched on this earlier in her presentation this morning, but how do we get that wisdom to make good judgment as it relates to other things in the system? So we've kind of entered into this new era, I would say. A lot of our area has been built out, it's been developed, and so we're kind of relaxing some of our previous knowledge towards this and kind of shifting towards nature-based solutions. A lot of our facilities are now kind of going through these retrofits, new forebays, new outlet structures, and kind of other ways that we've learned over the year to improve things as they go. So what types of monitoring do we do? One of the big things I think that we have learned over the course of the past 5 or so years, with definitely the help of some of the former interns. I know a few of you are definitely out there in the audience today, but we do a lot of monitoring in terms of the acronym here is AIMS, kind of assessments, inspection, maintenance, and sampling. And so all of this is really post-construction, so this idea of operational monitoring really has kind of informed some of this effective maintenance practices that we've used. So over the past couple years, we've performed a bioretention study where we went out to about 50 plus facilities and collected data on all these facilities because the data is what we use to make informed decisions. Some of the things that we looked at are the design characteristics, things like imperviousness, run-on ratios, and so on. Other things that we've looked at too are kind of the hydraulic performance, performing infiltration tests, assessing vegetation, collecting soil samples, so pretty much everything except for water quality. But we've been working a lot recently on getting our final report out, which should be coming up this summer, and so excited to kind of share a lot of that because you can imagine 50 plus facilities, there's thousands of photos, and so trying to compile all that down into a 15-minute presentation definitely was a bit of a challenge. So just real quick, some of the facilities that you'll see throughout this presentation includes River Run, 21st and Broadway, but this site map that we have here is what we've used to go out and collect our data and report this information. But I'm going to use these facilities here to really highlight some of the key themes, which we're going to call regimes in this presentation. So everything starts with design. So kind of understanding here, how can we design for maintenance in a world where we have to balance all of these different regimes? And it really is a balancing act. So based on some of the work that we've done, we've kind of segmented this into 3 different regimes. What's the flow regime, meaning how much water are we receiving? How is that water being distributed? The pollutant regime is what's coming into our site, how are we storing it, how are we collecting it, and then kind of this maintenance regime of how do we perform the maintenance, how do we effectively kind of manage and maintain these facilities, as well as how do we document some of the operations that we're talking about. And so This slide right here, I think, was something that was really kind of eye-opening to me last night, was how do I kind of bring this all together? And I think that kind of this idea of dependencies, where the flow regime really depends on some of the design characteristics, the storm event, but the pollutant regime kind of depends on that flow regime. How are things transported? How do things enter our facility? Where are we collecting them? Kind of the human factors, which are always the biggest factor, I think, in all of the things related to stormwater design. And then this maintenance regime. And so that depends on the flow and pollutants, as well as kind of frequency, level of maintenance, kind of our operational practices. And so all of those kind of combined together really kind of have created this balancing act that we need to work through. So very similar to, for those that attended last year, lanes balance, kind of thinking of it as a balancing act. I know Dave gave a good presentation where it showed the scales. And so very similar. We're just talking about smaller systems that are upstream of our streams. And I think that's kind of really key here. And so before jumping into each of these, I wanted to kind of highlight one of our sites. So this is a river run park, Bioretention, in Englewood, Colorado. It's connected to a golf course and a parking lot. One of the things that we've noticed over the years, though, this is an active stormwater monitoring site, so we actually do collect water quality samples, but kind of we've noticed that there's these sections that have kind of formed in our facility. Kind of the green is the entrance, the blue is the middle, and then the orange is kind of the end of the facility. And so we're talking bioretention facilities here, not detention. And one of the things I think to highlight here is just kind of all of these dynamics really have played a part in this area. And so as we entered the facility, we found that native vegetation had a hard time to establish. We've also seen a lot of weeds grow, other challenges that we've kind of have had to rely a lot on maintenance and maintenance practices, as well as just the sediment deposition. And so we'll touch a little bit more on this in the next slide, but this idea of kind of one entrance point instead of distributing the flow evenly across the site has definitely been a bit of a challenge. And so kind of how do we design for this in a way that can really benefit the site, but also improve water quality as it's gone on. And so this site itself, infiltration, we performed tests throughout the site, and what we were finding is that the end of the facility, which might actually not receive much runoff, still has some of the best vegetation that we've seen in terms of native vegetation. But the area in green that's up front has been a little bit more challenging to establish that, and there's actually a little bit of a case study that you'll see later coming on is what happens if we don't do maintenance for a year. So jumping right in, the first flow regime, some of the things that we were finding really kind of culminate in all of these different, like understanding the site is really what's key here. And so how is flow being distributed? Are we talking single inflow points or multiple inflow points? Are we talking concentrated inflows or sheet flows? How are we developing the site? I think that's something that we've really kind of tried to incorporate some of these soft engineering practices a little bit more, and rather than just installing one large detention facility, kind of distributing that upstream. And so some of these new concepts that have been incorporated into the criteria about when to use certain types of facilities is all kind of stemmed from some of this research, as well as the knowledge that others have shared as part of the stakeholder and collaboration process. So outside of that, I mean, there are a few other things here that kind of really touch in on this flow regime, but to keep things moving, just kind of wanted to highlight some of the sites that we've seen. So this is Carla Madison Recreation Center. It's very distributed, a few different bioretention facilities. What's nice is that this is a community value. It's not something that's kind of hidden away, but it's actually incorporated into their parking lots. And kind of looking at this during a storm event, one of the big things that we're seeing here is that they're utilizing the entire surface area. So whereas River Run, most of the things infiltrate in those first 50 or so feet, everything else is kind of being left dry. Here, we're actually utilizing that full surface area, ponding it, and allowing that water to slowly infiltrate into the subsurface. The CDOT headquarters is another example. So they have 5 different bioretention facilities here. If you were connected to parking lots, and again, this idea of distributed detention, how are we actually able to infiltrate the water, kind of break these drainage areas into smaller systems that actually utilize. And so these past 2 sites, the vegetation was doing fantastic, and I think a lot of that is attributed to this distribution of water evenly across the sites. So this next one is not so good of one. So one of the challenges I think that we found here is that there are some issues related to the subsurface drainage. One, it's being very close to river, so groundwater is definitely an issue. But two, there's over 150 acres that are draining to this site. There's two 60-inch stormwater facilities, and so maybe a bioretention facility is probably not the best case in this scenario. The next was the pollutant regime. So kind of touching on this, like I think some of the big things to really highlight here is what are the loading sources? Kind of understanding roadways and parking lots, residential areas. Roadways and parking lots bring sediments. Residential areas kind of bring nutrients and weeds. Ultra-urban area, that's where we get the trash, debris, as well as some other sediments. But also, what are ways in which we can collect this first before it actually enters into the system? So trying to think of a bioretention system as multi-part. So you have that kind of forebay, those pre-treatment options. Also, as well as some of those non-structural practices like street sweeping and actually performing maintenance at a frequent schedule. And so I think those are some of the things to highlight here as it relates to some of this pollutant entering into our facilities. So again, this is one of the kind of a nice Google auto creates it for you. But anyways, this is our river run site, and one of the things that we found is like looking at the sediment as it enters into the facility. We're talking a parking lot and roadway, definitely a lot of challenges here. And so you can see in the figure on the right, this is sediment from an H flume compared to sediment from the compost. And it's very dried out, but just looking at those fine particulates. And so we've collected some of these samples, and I think some of the things that are really interesting is kind of looking at that inlet and outlet comparison. So the outlet first is actually very similar to the media that we currently have. It's not receiving a lot of sediments or inflows. But the inlet itself, we're talking nitrate nitrogen, which is about 16 times more, phosphorus 2 times more, zinc 56 times more, copper 3 times more. So it really highlights some of the importance of these maintenance practices that are performed upstream or other options that we can have. It is a balancing act, so maybe a larger forebay or other ways in which we can kind of collect, store this before and actually properly remove it rather than having it enter into our facility. One of the things I think that has been a challenging, especially when we design for maintenance, has been making sure kind of to understand what's that adjacent land use. Do we have active construction that's going on in these areas around it? Because if we do, we're likely to overload our facilities, reduce that infiltration rate. It causes vegetation to struggle a little bit. And so this idea of innovation, I know Candace has touched on this a lot, but this idea of innovation as it relates to some of our facilities, shout out to Denver and Doty for some of these ideas, but within these facilities themselves, there's this kind of benefit of using the vegetation to kind of store and collect some of that sediment. So concrete pads are great, adding a lip to them is even better. And so this idea of how can we incorporate innovation as it moves forward. So the last one here is maintenance regime, and to kind of touch on some of the things here, this is what not to do in a facility, but things that we do need to understand is that each of the facility is different. Kind of this prescriptive versus adaptive management approach to maintenance, not just having a cookie cutter, here's how to go out, here's how many times you need to go out, but actually getting folks out to these facilities really helps to extend their lifetime, to reduce some of these additional costs that I think you'll see with proactive maintenance versus reactive maintenance. Another thing too here to touch on is just this idea of education. So making sure that folks do know that these are stormwater facilities. Don't store a bunch of snow here, and this is, I think, several days after a snow event, and it's gonna take forever for this to actually melt, and then once it does melt, we're gonna have a bunch of sediments in there, and it's gonna create a clogging issue in the future. So this idea of getting away from annual to kind of biannual, I think that you really do get to see a lot, or even going after a storm event. And I know my interns here before, I've just said, hey, if it's raining, go out, look at some of these facilities, collect some photos, because you can really learn a lot during the storm events, especially here in our climate. So this idea of frequent maintenance, especially during establishment periods, shout out to the crews in Denver for the Greenway project. They had folks going out there a lot to actually kind of understand that these need more attention during that construction phase compared to after the construction phase. Did a little case study here, kind of understanding what happens when no maintenance is performed. I can tell you the bill is 3 or 4 times what we wanted, and we still have to do maintenance after. So getting more frequent maintenance out to some of these sites is really important. Here's another slide itself, kind of the end of River Run, kind of looking from the back of the facility and then moving forward from there. Another one to kind of highlight here is the 21st and Broadway, and I think one of the things that we learned here is just kind of this is an area ultra urban, so maybe there are some other ways that we can incorporate kind of forebays, kind of covered forebays to protect it from seeing some of those things. So overall, what do we learn? There's expectations versus reality, ways that we can distribute flow to benefit vegetation, kind of this idea of pre-treatment, which has been incorporated a lot into the criteria manual. Documentation has been a big one too, so making sure to kind of modify these adaptive management approaches, and then the importance of learning from some of these past slides. And so one of the last slides here just to kind of highlight some of the things that we have going forward. There is, can I go back? Maybe not, there we go. So some of the things coming forward, the report's coming out soon. We have some research related to some street sweeping and some retrofit studies coming out, as well as some research on other stormwater control measures. And then going from some of the work that we're doing is how can we kind of bring this all together in a way that we can share, so these data sharing hurdles that we are discovering. So some recognitions here. The only person I don't have on this, and she's going to get a shout out, is Kirsten. So thank you very much for all your help on this. I wouldn't be able to do this without the support and funding, as well as all of the interns that have really contributed to this. So that's all I got. Thank you.